Hello, my name is Michael Carty, and this is my teaching demo on how to derive the quadratic formula. I'd like to thank you for watching. So let's go ahead and get started. So what we have here is the standard form of a quadratic equation. And what we're trying to do is we're trying to find out solutions of x that makes this equation true. One way that we took a look at is by factoring. But not everything can be factored, so that's why we looked at completing square. And we're going to use completing square for a general quadratic formula, and we're going to get another method that we can use to solve quadratic equations. So remember that our goal in all of this is to solve for x. And in this case, we don't have numbers for our coefficients a, b, and c, but we do have a way of solving this by using completing the square. So that's the method that we're going to be using to solve this general quadratic equation. So remember through all this, our goal is to solve for x. And we're going to use completing the square. And remember that we can use completing square once we have a leading coefficient, in this case a, of 1. And we don't have that yet. So what we need to do is we need to divide each term by a in order to start using completing the square. So we're going to divide each term by a. So here we have, we cancel out that a in the leading term. B divided by a times x. And then c over a equals 0. So now that we have a leading coefficient of 1, we can start using completing the square. So remember when we're completing the square, we're using these first two terms to make a perfect square trinomial out of those. So this c over a over here, we're going to subtract that and move it to the right-hand side, leaving us with the first two terms, and then c over a on this other side. So now we need to find out what we need to add both sides by in order to complete the square. Which means that we're going to take this middle term, and we normally divide by 2. But multiplying by 1/2 gives us the same result. So what we're going to do is we're going to multiply 1/2 to b over a, giving us b over 2a. And that's what's going to be in our binomial on this right-hand side, the result of the perfect square trinomial. So over here we're going to have x, keeping this sign here, plus b over 2a squared. So that's our first part. Now over here on this right-hand side, we need to square what we have here in green and add that to the right-hand side. So when we square b over 2a, we're going to add that to negative c over a. So we know that right here, we're going to end up taking the square root of both sides, the positive and negative square roots. But let's go ahead and clean up this side over here. It's kind of messy, and make it a little more simplified. So for right now, we're going to leave the left-hand side alone. So we're going to apply this square to both the numerator and denominator. So 2a squared is going to be 4a squared minus c over a. So what we have over here is we have two fractions that we're subtracting. And in order to add or subtract fractions, we need common denominators. And you see here, if we multiply that second fraction by 4a, if we multiply it to the denominator, we get 4a squared for both of these. So whatever we do to the denominator, we have to do to the numerator. So we're going to multiply both the top and bottom by 4a. So what that gives us is 4ac in the numerator and 4a squared in the denominator. Now that we have common denominators, we can subtract the two numerators. So now that this right-hand side is cleaned up and simplified as much as we can simplify it, we can go ahead and do what we said before, and we can take the positive negative square root of both sides. And the square root cancels out the square for the entire binomial, so we're left with what's inside the parentheses. And over here, we got to make sure that we have the positive and negative square root so that we have all of our solutions. So we have that square root that if we're taking the square root of a fraction, we can split up that square root and apply it to the numerator and the denominator. So it's not going to really change the numerator that much because we cannot simplify when we have an addition or subtraction sign. But we can simplify the denominator. And when we simplify the denominator, square root of 4a squared, the square root of 4a squared is going to be 2a. So we're just going to take the square root of both parts. So what we have here, square root of 4a squared is 2a. So here we're almost done because remember our goal is to get x by itself. And we have x in a term by itself. So all we have to do now is subtract this b over 2a over to the right hand side to get x on one side by itself. Alright, so we're almost done. We just need to simplify this right-hand side over here. And since we're adding and subtracting fractions, we still need common denominators, which we do have. We have common denominators of 2a. And just because we have a plus or minus sign in there, doesn't change the fact that we're adding and subtracting at the same time, and we still add and subtract the numerator. Okay, so this gives us our final form of the quadratic formula. So this is the quadratic formula. And we can use this with any quadratic equation to solve for its solutions, the values that make the values that will make the equation equal to 0. And this will give us real solutions. It'll give us the complex solutions. We're not limited to any certain type of quadratic equation here. So this is the final result of the quadratic formula. So that's it for today. Thank you for watching. I look forward to talking to you very soon.